if you're interested in stuff.
Well, it looks like the attendance is incredibly light. That said, we will hang out a minute before we just kick it off and record it and post it on the microsite anyways.
Yeah, we can use the recordings at a minimum.
Well, let's just dive in.
Sounds good.
Cool. All right, well, we will edit this out. Hey everybody, my name's Ellis. I'm the founder of Crack Labs and the president of Web3 and AI at Hacker Earth, and want to thank everybody for joining us for the Say All-Star Hackathon. First technical deep dive, getting started with Say. Got Carson on the line, who is one of the core engineers with the Say Labs team. Carson's going to introduce himself. We'll go through a little presentation and then take some questions from the audience.
Yeah, thanks. My name is Carson. I'm one of the core engineers, as you mentioned, on Say Labs. Been working with the Say team for almost 3 years now. Really exciting times to Say. So excited to get into this and chat more about things with you.
Awesome. Now, Carson, we're doing with Say 2 separate hackathons at the same time, right? We've got one going on with high schoolers. Of course, I'm knocking a bunch of stuff off, so disregard that. But got one going on with high schoolers. We've got another going on with college students, where there's different levels of, let's call it, difficulty. That said, I'm sure you've probably seen a few things in your day at Say. What do you think people should expect before they're diving in or getting under the hood? Are there some pointers or some things that you would want to tell them ahead of time, just so that, you know, they're not going to have their hair catch on fire?
Yeah, well, one thing that you mentioned is, like, you know, maybe there's some high schoolers or maybe there's some graduate college students. And the nice thing about Say is it has a standardized EVM interface, so it's really easy for new people to get on board, but a lot of the optimizations that Say has done has also made it really useful for the most experienced and advanced blockchain devs to build. So we really kind of have something for everyone. It makes it really easy to spin up something if you're new, or to build the next generation of apps in crypto with the latest tooling.
Awesome. What would you say to somebody who's very new to Say is the defining feature or features that make it critical to what it kind of is? So why did you choose Say, I guess is a great question too.
Yeah, I mean, I think fundamentally Say solves a lot of problems that exist in the blockchain space right now, particularly within EVM space, but in general, that transactions are slow, they're expensive, they happen at not quick enough intervals. So Say being a parallelized EVM, having fast finality and quick block times allows you to create applications that are not only performant, but work well with other ecosystems. So it's a full set of tools. It's a full ecosystem that anyone can build anything that they can imagine on.
Awesome. I will certainly come back and ask questions after the presentation, so I'm going to actually just bow out and give you the floor.
Okay.
We'll come back, ask some questions from on my end. We'll then open it up to the floor as people kind of trickle in. It looks like we've got people kind of coming in one at a time.
Okay, awesome. Let me share my screen.
Cool. Thanks, Carson. I'll be back.
Yep. Okay. Okay. Have a little presentation here. We'll get started. We'll intro a few things, and then we'll actually get into a little bit of code and deploy a smart contract. So yeah, thanks everyone for joining. Welcome. As mentioned, my name is Carson. This is actually what I look like. Core engineer on Say Labs. So what is Say? So Say is the fastest layer 1 blockchain, simply put. It has, as mentioned, really quick block times and finality, about 400 milliseconds. It has a lot of users, 350,000 plus daily active users as of yesterday. A lot of these people are here because it has low fee, it has high throughput, like with 12K plus theoretical TPS. And we're the first ones to have a parallelized EVM. Everything else is just single threaded. So that's where kind of Say is now. Wanted to shout out this Giga upgrade that was announced, an internal testnet with 5.4 gigagas and over 100,000 TPS. So it's something exciting to look forward to coming up. So I've mentioned that Say is a parallelized EVM. What does that actually mean? So Say actually has two VMs. Say has EVM and it has CosmWasm, but for this chat, we're going to be focusing on EVM. There's a lot of chains that have EVM. The most common one, or most well-known, it would be Ethereum, where it gets its name from, the Ethereum virtual machine. But pretty much every L2 and some other L1s, even newer ones like Berachain, are EVM compatible chains. So what does that mean? It means they all have a standardized RPC interface, or basically an API interface. How you query the chain or execute contracts, all of that's standardized across all of them. It has a standardized address space, so an address on one is typically going to be the same on the other, with some exceptions there. All transactions are going to look more or less the same across all of them, and typically they have smart contracts that are written in Solidity or Viper, which is a more Python-based smart contract language. So why the EVM? It's the most commonly used stack in crypto. It has the most developers, has the most jobs. Every year, Electric Capital puts out a big developer report. And you can go through and read that. It's pretty interesting. I've linked it here. I'm just talking about the different ecosystems in the crypto space, directions that they're heading. Lots of useful information, especially for younger people who are just getting into the crypto space. So now we're going to go through and we're going to actually build and deploy a simple Solidity smart contract on Say's testnet. It's going to be a smart contract. It's going to be real simple. It's going to store a global integer value. It's going to have a couple of functions. One of them is going to be to query that global integer value, which is going to start at 0. And another one, which will be you can execute a transaction to increment that value. And then if anyone else queries it anywhere in the world, they should see the new incremented value. So there's a link here, which we'll follow along. There's also a couple other helpful resources like a block explorer for the Say testnet. some RPC URLs, which we'll need. And there's also a faucet in order for people to get testnet tokens for the first time. So I'm going to back out of this. I'm going to go over to this tutorial, and feel free to follow along. This is on the Say docs, so anyone can go ahead and try this out for themselves. So we're going to be building this contract, as mentioned, with Solidity. We're going to use Foundry Forge, which is really common EVM tooling. If you don't have it installed, there's some links here on how to install it and also get a little bit of background information on it. It's probably the most common tool used by EVM developers. So we'll be assuming that you have it installed. If you don't already, go ahead and follow these links. So first thing we're going to do is we're just going to create a new project in Foundry. So I have a new directory, blank directory set up here. So I'll just go ahead and do Forge init, and we'll do it counter example. So this will spin up a new Forge project, basically boilerplating everything for you to write a smart contract. So from here, we'll see that there's a couple directories in here. There's a source directory with a counter smart contract, real simple, and some test files, because it's always good practice to test and write tests for your smart contracts. So I'm going to copy this over here real quick, and then I'll walk through kind of what we're doing here. So just adds a couple things. This is a counter smart contract. As you can see, there's a unsigned 256 integer here named number. It's public, so anyone can read it, set it. There's a function here to set the number. It takes in a new integer and resets this one that's stored on the contract with the new integer. There's also an increment function, which will just increment it by 1. And there's a public view function, which allows us to query it, which will just return the number. There's some tests here, which, as I mentioned, we always want to make sure that our tests are up to date. So these are tests for this, basically just asserting certain conditions according to the logic that we expect here. So now that I've added this code here into this smart contract Solidity file, I can test this by running forge test. At least it should. Oh, you gotta go into the directory that was created. Cool. So it looks like all of our tests passed here. From here, we can actually just deploy, build and deploy the smart contract right to the Say testnet. In order to do that, we're going to need an account to deploy from. So there's a couple ways to do it, but I just have a fresh MetaMask set up here, which I just added. In the docs, if you want, MetaMask by itself doesn't have the Say networks enabled by default. But if we go to the docs and we go to user quick start, we can just connect our wallet here in the docs, and it'll prompt us to add and switch to Say testnet. So this will set up your MetaMask. At least it should. Something up with live demos. That's okay. We can get our, as I mentioned, addresses on Ethereum, on Say, on most EVM chains are the same. So if you have an account with the same seed phrase on Say versus Ethereum, you're going to have the same address. So what I want to do here is I want to just go get a little bit of faucet tokens from the Say docs on testnet. So I'm going to verify my captcha real quick and click on some dogs. And I will request some Say so that I can deploy. So we will go back now to this tutorial, and we're going to actually deploy it. So there's a command here. You'll see that it's forge create. We have an RPC URL, which we'll get one of these. We'll deploy it with a mnemonic seed phrase, which I've already exported into my terminal, but you can get this from your wallet, whatever wallet provider you need. We're going to tell it that counter Solidity file, we're going to name it counter, and we're going to broadcast this. So I've already set up say node URI, but if you want, you can come to Rhino, has some good RPC URLs, and we'll have this right here. So we can you can use this RPC endpoint when deploying here. So let's go ahead and try this. Since I've already set my mnemonic and the say node URI, oh, I copied the $sign. So we can see now that this is deploying, it's compiling and deployed. This is deployed to this contract address. So this is where our contract exists on the say testnet. We can view the transaction hash here. If we go over to the Explorer and just paste this in here, we'll see that this was a testnet transaction and that it was deployed successfully 19 seconds ago. So from here, let's test this out. So let's copy this command here. What this is doing is it's using cast. It's going to call our contract address, which I will paste here. And we're going to get the count. So I copied the $sign again, sorry. So as we can see, the count is 0. Nobody has incremented this count yet. So let's go ahead and try that. So let's call this command right here, which we'll see. We'll call our contract address, and we're going to call that increment function that we defined here, which is just going to increment this. So let me copy this over. Replace the contract address. And let me delete this extra $sign. So this is actually going to send a transaction using our mnemonic seed phrase. You can see all of the values here. Standard EVM transaction again, or I can grab the transaction hash here and go back to our Explorer, and I'll paste this in here, and we can view that this was a success. We successfully incremented it. There's some details in here if we want to debug them a little bit, but let's just go back one more time and call our get count function. We should see the value of 1, and there it is. So anyone who calls this function right here with the Atlantic 2 node URI should see a value of 1 unless somebody else comes along and increments it. And so that's the nice thing about these smart contracts is we now have basically an application out there that anyone in the world can use. It has all of the infrastructure behind it. So typically when developing in Web 2, I mean, you'd have to set up an API, you'd have to set up a database, you'd have to deploy it all, you'd have to host it all. And that's really one of the benefits with blockchain in general, and especially on Say with how easy and cheap it is. It's also super fast. You notice like I execute transactions and within a half a second, those transactions are finalized. So a couple other quick notes before we wrap up this. Foundry does generate an ABI for each smart contract. This is really useful when calling these functions from like a front end. And there is a section right here showing you how to actually call these using something like Ethers.js, but any common front end library like WAGMI, Veeam, even Web3.js, you could use the ABI from this out folder. And then you'll be able to call this from JavaScript, from a React application, an Next.js application, or even just a Node.js script, whatever you prefer. So that's really what it takes to deploy a smart contract on Say. As I said, it's super simple. Let me get back to this. And honestly, it works with all common EVM tooling. So things like Forge was originally made for Ethereum. Other tooling like Remix or Hardhat, they all work too. So if you're well-versed in Ethereum or EVM development, coming over to Say is going to be super familiar. I mean, it's going to be the same address spaces, same RPC interface, same smart contracts. I mean, they can be deployed with 0 code changes. You can even use like Way in a Say smart contract, and it'll automatically just use Say instead of Way. So smart contracts that have already been written on EVM can be deployed on Say very easily. A little bit more about Say, if you want to continue building with us. It has a really big ecosystem. It has a full set of stable coins, has liquid staking tokens, full set of DeFi primitives. I mean, you got swapping, you got DEXs, you got lending, anything that you can imagine. You kind of have options for all of them. There's NFTs, marketplaces, things like Magic Eden, launch pads, Beam coins, huge gaming ecosystem. There's oracles if you want to bring off-chain data into your smart contract for, say, some condition. Indexers, in case you want to basically create a backup Web2 database of transaction data so that you can query it quickly and efficiently, and a whole bunch more. I mean, Say is a fully built out ecosystem with all sorts of partners. You can check out say.io/ecosystem to view some of the projects that are deployed on it and play around with it. I recommend just getting a wallet, getting some Say, going and trying swapping, going and trying some of these DeFi applications. And last thing I'll leave is just some of the advantages of Say. Like I mentioned, it has quick block times. It has the highest throughput, like orders of magnitude more than other chains. Orders of magnitude lower fees. It has a really battle-tested infrastructure, being live for coming up on 2 years now. Has higher gas block limits. So really there's a lot of things that can only be built on Say, given the constraints of other ecosystems, especially in the EVM world. So with that, I mean, if there's any questions, feel free to ask them. Here's some links for you to just stay in touch with us. View the docs if you want to build some more stuff. If you're more academically minded and you're interested in the research and the optimizations that Say has done, you want to really get into the nitty gritty and even like the math behind it, check out sayresearch.io. There's some really good stuff there, especially on like the Giga research that's been going on. Honestly, there's things going on in Giga that are not happening anywhere else in crypto. So worth a read there. You can join us on Discord. There's developer chats. There's general chats. We have developer office hours every week. They're actually going on right now, but you can feel free to join us next week if you want to, and follow us on Twitter. I mean, there's always things that we're posting. Twitter's a great way to not only learn about Say and learn about what's going on in the ecosystem, but to connect with other builders and to just get plugged in with the Say community in general. So with that, if there's no other questions, I can kick it back over to you.
There we go. StreamYard's always fun. I think we had a little bit of a technical issue with the screen share at the beginning, but we got it resolved towards the end. Well, let's take a second and answer any questions that might come in the chat. Doesn't look like there's really any right now, but for those of you that are with us, do you have any questions that you'd like to pose to Carson? Sorry, I just got a sneezing attack. Okay, so it didn't look like there's really any questions in the chat. Carson, awesome job. Let's see. There you go. Dropped your Telegram in there. Perfect. So those of you that are listening, or those of you that are going to be listening at home later, feel free to reach out with any questions. You can ask the Say team questions directly in the Telegram groups, and everybody's very responsive. We're all here to support as you are building. So if there are questions about integrations, about deploying smart contracts, about getting started from scratch, do not hesitate. And well, we're excited to see what you build. So we'll just call it a day with that. Carson, you're the man. Appreciate the time. Have an awesome rest of your day. And to everybody in the hackathon, good luck building.
Right on. Thank you.
Thanks, everybody.